Hello and welcome to Math Valley. Today we have a problem from the chapter Circle, which is a HOTS problem, and based on the concept of a theorem of touching circles. So without making any ado, let's see what exactly the problem is. Two circles touch each other internally. Okay, so we have two circles which are touching each other internally. Then distance between their centers is a 5 centimeter, which is given, and radius of the bigger circle is 13 centimeter. Then we have to find the ratio of areas of smaller circle to the area of the bigger circle. Okay, this is what been asked. So without making any ado, let's solve it. As you can see in the figure, we have two circles with center A and B, which are touching each other internally at point C. So let's declare this thing in the beginning of the solution. Let circles with centers A and B touch each other internally at point C. Also, we have to consider that R1 is the radius of bigger circle and R2 is the radius of smaller circle. So we'll write also let R1 is equal to 13, which is equal to radius of bigger circle, and R2 be the radius of smaller circle. So R2 is equal to radius of smaller circle. As we define the radius or radii of a bigger and smaller circle, so we can certainly write that R1, which is greater than R2. Why? Because R1 is the radius of bigger circle and R2 is the radius of smaller circle. That is why R1 is greater than R2. Also, distance between the centers means the distance between points A and B, which is the length of segment AB, which is given. AB is equal to 5 centimeter, and also radius of bigger circle, which is R1, is equal to 13 centimeter. Now, to find the ratios of areas of these circles, we must know the radii of each circle. So we have the radius of a bigger circle, which is given. Now we have to find the radius of smaller circle. So to find that, we have to use the concept of internally touching circles. So what is the property of two internally touching circles? What the properties state exactly? Distance between two circles touching each other internally is equal to the difference of their radii. So this is nothing but the property regarding the internal touching circles. So according to this property, we can write a statement: distance between A and B, which is the distance between their centers, is equal to the difference between their radii, that is R1 minus R2. Since R1 is the radius of bigger circle, we wrote it as first. So we can write the reason as a property of internally touching circles. Okay. Now just replace the values. Since we have the distance between the centers, that is AB, is equal to 5 centimeter. So we'll replace this thing with 5, and we have R1, that is the radius of bigger circle, is 13 centimeter. So we will replace this R1 with 13, and now we have to find R2, which is the radius of smaller circle. Therefore, it will be further modified as R2 is equal to 13 minus 5. Therefore, R2 is equal to 13 minus 5 is 8 centimeter. So now we have the radius of smaller circle also. So simply we can find the ratios of the given circles, that is a smaller circle and bigger circle, and through that, using those areas, we can find the ratios between smaller circle and a bigger circle. So just write it down as area of, first I have to differentiate this, area of a smaller circle divided by area of a bigger circle. So what is the area of the circle? What is the formula for that? So we have formula for the area of circle is pi r square. Since the radius of smaller circle is r2, we will replace this r with r2 square divided by r1 is the radius of bigger circle. So we can write the formula for area of bigger circle as pi r1 square. Now just replace the values. This pi and this pi in the numerator and denominator will be cancelled out with each other. And R2 which is equal to 8 centimeter. So we can write square of 8 divided by, and R1 is equal to 13 centimeter. So we can write square of 13. Now square of 8 is 64 and a square of 13 is 169. Since 169 and 64 don't have any common multiple other than 1, so these ratios will not be cancelled out. So this is nothing but the standard form of the required ratio. So finally we can write, therefore the required ratio is, the required ratio is 64 is to 169, and that's our final answer. Okay, I hope you enjoyed this video. If you like this video, you can press the like button just below the video title, and if you want some exciting, some interesting, some funny videos related to math, you can subscribe to our channel. Thanks for watching this video. Have a great time. Hello.